I want to make a quick vodcast about graphing rational functions. I made this handout that kind of steps you through a lot of the various steps, and some of these aren't going to happen in this vodcast, but this is kind of a guide, and it says at the top, you're going to need to do a bunch of these things so that you don't need these notes anymore. We're looking for excluded values, vertical asymptotes, horizontal asymptotes, oblique asymptotes, holes, x-intercepts, y-intercepts, all those things, so we can get a good picture of what this graph is going to look like. You should have this handout in front of you if you want to follow along. I'm not going to keep flashing this up. I'm just going to kind of refer to some of these steps. And I may do them out of order, but they'll all be in there. So the order doesn't always completely matter. But here's the equation I have. On the left is the equation in standard form, expanded form, and both forms are actually handy for what we're going to do now. One of the steps says to factor it completely, which I've done on the left. And the next thing it says to do is list the excluded values, which of course would be x is equal to, okay, x cannot equal 6, x cannot equal -7. Those are going to be the vertical asymptotes, or rather x equals 6 and x equals -7 will be the vertical asymptotes. This one didn't simplify at all, so there are no holes, because holes would occur if a factor in the numerator and a factor in the denominator canceled each other out. So we don't have to worry about that. We want to know what the x-intercepts are, and they are the values that make the numerator equal 0. So that would be x is equal to -1/2, 0, -1, 0, -4, 0. Those are our x-intercepts. Our y-intercept is easiest to find if we look at the non-factored form over here, and that would be if I do r of 0, plug 0 in every place, I'm going to be left with -4 over 42, which is equal to -2 over 21. Okay, so our y-intercept is going to be 0, -2 over 21. So far we've got vertical asymptotes, x-intercepts, y-intercepts. Now, one of the things it said on that handout is whether looking at horizontal asymptotes or oblique asymptotes, we're going to get a horizontal asymptote of 0 if it's bottom heavy, if the bottom is growing faster than the top. It's going to go to 0. And remember, the horizontal asymptotes are talking about the extremes, and so is the slant asymptote or the oblique asymptote. It's talking about when x is very big, going to infinity, or x is going to -infinity. It's not what's happening. That has nothing to do with what's happening like between asymptotes or kind of in the middle or closer to 0. So this one happens to be top heavy, which means we have to do polynomial division to find the slant asymptote. That's, as you remember, going to look like x squared plus x minus 42 divided into 2x cubed plus 11x squared plus 13x plus 4. Remember, as you're doing polynomial division, if there are missing terms here, then you would have to put in 0x squared or 0x or something like that. So x squared goes into 2x cubed, x times. I'm sorry, 2x times. So we put a 2x up there. Actually, I should put it way over here, shouldn't I? Should put it on top of that. And then I multiply and I get 2x cubed. 2x cubed, and I get plus 2x squared minus 84x. Not crazy about these big numbers, but oh well, what can you do? Now I'm I'm going to change the signs here and add. So I get 2x cubes cancel out. I get 11x squared minus 2x squared, which is 9x squared. Oops, I'm still on red pen. That's okay. And I get something like plus 97x plus 4. And then I think we'll put back black here. And then I divide in again, and x squared goes into 9x squared plus 9. And I multiply, and I keep multiplying. And I get some big number here that I don't care about. This is going to all subtract out. We don't care about this. We know we're not getting 0 here. Y is equal to 2x plus 9 is my slant asymptote, or my oblique asymptote. Okay, so we have this, and we have all this information over here, and we're going to put that on a graph, and I have saved time by doing a little pre-setting up of the graph. See if I can remember all these things. 2x plus 9, here's my line, so this would be 9 here, and this would be negative 4.5, I'm sorry. And that's that. The vertical asymptotes are 6 and negative 7. It's positive 6, so this is going to be positive 6. This is going to be negative 7. By the way, this is the y-axis. I should put that on here. And this is the x-axis. Always label your axes. And the x-intercepts are negative 1/2. Let's put that right there. Negative 1/2. Negative 1. Not being real careful about scale, as you can see, and 4. And then the y-intercept is, what was that, negative 2/21. Now, here's how I've been doing and telling you what to do when I've been explaining this is think about, in this factored form, we have 5 factors. When you get far enough to the left, they're all going to be negative. That means the whole graph's got to be negative all the way over, as you're getting very, very negative. That means it has to stay negative all over here. Okay. And then it's going to get closer to this asymptote, which maybe I can stretch this down a little bit. Okay, it's getting closer to that asymptote, but it's got to stay negative. Now, as it crosses that asymptote, one of those factors, the x plus 7 factor, is going to turn positive on the other side of negative 7, right? So now you have 4 negative ones and a positive one. That's positive. So it must be way up here. And remember, this asymptote doesn't count anymore in between these. We're inside, we're not out in positive and negative infinity, we're just close to 0 right now. So that asymptote, if I could erase it, I would, but I'm not. So it's got to be coming up from here, and it's got to go through 4, and then it's going to turn negative, and then it's got to turn back up again, and it's going to change sign each time it goes through one of these things. And then it's got to go through the axis there at negative 221. And then it's got to go zooming down. It's going to be not so bumpy like this. It's going to get closer to that vertical asymptote. Then as it crosses over 6, it's got to be positive forevermore after positive 6. Okay, the only way, and it's got to get closer to these asymptotes. So it's got to get close to that asymptote. And then as it zooms out to infinity, it's just got to get closer and closer to that slant asymptote. And so our graph is going to look kind of like this. It's not going to look so bumpy when you do it, but and maybe yours would fit all so you can see it all at once, but that's it. All right.